Most engineers are repeating the exact same footing mistake on sites all over the world. And the worst part? It silently weakens the entire building from day one.
You won't notice it at first. The concrete looks solid, the columns go up straight, the handover goes perfectly. But beneath the surface, a ticking time bomb has been set. You won't know anything is wrong until the cracks start appearing.
Today, we're breaking down the #1 silent killer of building foundations. We'll show you exactly how it happens, the terrifying site impacts, and the step-by-step method to ensure your structure stands the test of time.
Let's get right to the problem. On far too many sites, contractors are in a rush. They excavate the foundation, clear out the bulk of the dirt, and place the footings directly on loose, disturbed, or heavily uneven soil.
I see it all the time. The site manager looks into the pit, sees dirt, and says, pour it. It looks absolutely fine when the concrete is wet. The concrete fills the gaps, right? But that's exactly where the failure begins.
Exactly. Soil isn't a static material, it's highly dynamic. When a structure's immense dead and live loads are transferred down to that footing, the footing needs a perfectly uniform surface to push against. If the soil beneath is loose or uneven, settlement starts.
And it starts slowly, a millimeter here, a millimeter there. But as the building gets heavier with each constructed floor, that settlement accelerates. You're no longer building on a solid foundation, you're building on a sponge.
So why does this happen? It boils down to 5 fatal flaws in site execution. First, poor soil preparation. Once you excavate to your founding level, the top layer of that soil is naturally disturbed by the excavator's teeth. If you don't remove or treat that disturbed layer, you're building on compromised ground.
Which leads directly to the second cause, no proper compaction. You can't just pat the dirt down with the back of a shovel. Without mechanical compaction, like a plate compactor or a jumping jack, the soil grains haven't locked together. The building's weight will do the compacting for you later, and you do not want that.
Cause number 3 is an uneven bearing surface. If your trench looks like a mountain range, your footing is resting on peaks. The valleys underneath become voids. This destroys your load distribution.
And let's not forget cause number 4, water accumulation. If a trench is left open, rain or groundwater pools at the bottom. Water turns hard, bearing clay into a soft, useless mud. Pouring concrete over mud is a guaranteed failure.
Finally, the overarching issue, ignoring load distribution. A footing is designed assuming the soil pushes back equally across its entire surface area. When these first 4 causes happen, the load becomes concentrated on tiny points of soil. The soil fails and the footing drops.
Now let's talk about the fallout. What happens when you get that dreaded phone call 2 years after the project is finished?
The most obvious sign is diagonal column and wall cracks. Because the footing didn't settle evenly, a phenomenon we call differential settlement, one side of the building drops while the other stays put. This literally tears the rigid frame of the building apart.
You'll walk into the building and immediately notice uneven floors. You'll see doors that suddenly won't close because their frames have racked out of square.
You'll see massive wall separation, where the masonry literally pulls away from the reinforced concrete columns, and in extreme cases, complete structural failure. The building is condemned, and someone is facing a massive lawsuit.
So how do we stop this from ever happening? It's actually simple, but it requires strict site discipline. Step 1, always prepare a firm, level base. Excavate cleanly and manually trim the last few inches so you don't disturb the bearing stratum.
Step 2, use a proper compaction layer. Bring in the heavy equipment, compact the natural soil, and if required by your geotechnical report, bring in engineered fill, like crushed stone, and compact that in layers.
Step 3, and this is a non-negotiable for me, add blinding concrete, also known as PCC. This is a thin 50 to 100 millimeter layer of lean concrete poured directly over the compacted soil.
Blinding is crucial. It gives you a perfectly flat, clean, and hard working surface. It stops the soil from absorbing the water out of your structural concrete, and it guarantees uniform load distribution.
Finally, before a single drop of concrete is poured, verify. Have the geotechnical engineer check the soil bearing capacity right there in the trench.
When you follow this method, the result is engineering perfection. You get a perfectly stable footing.
You get an even, predictable load transfer from the columns straight through the footing and safely into the earth. Ultimately, you get a long-lasting structure that lets everyone sleep well at night.
The takeaway here is simple. Never, ever skip soil preparation.
Trying to save a few hours or a few $100s in the trench can result in a multi-million-dollar disaster down the line. Do it right the first time.
If you found this breakdown helpful, make sure to hit follow for more real-world site-tested engineering tips. See you on the next pour.